Hi! This is a video that's meant to supplement the U of U videos on inverse trig functions. At the very end of some of the homework assignments about these trig functions, there's some questions that ask, what is the domain of this composition of inverse trig functions? And that didn't come up in the U of U video, so we're going to talk about it now. Okay. What you see in front of you is an example from the U of U video. It's example 4C from video 12. And in it, the point was to compute the secant of cosine inverse of the expression 3x over 2. Okay, and the work is shown here and the answer is here. Now what if, in addition to being asked to compute it, you were asked to find the domain? Find the domain of this expression. Okay. Well, before we jump into actually finding the domain, it's good to think about what we know about the domain of the cosine inverse and of secant. And before we think about domain of cosine inverse, we'll actually think about the restricted domain of cosine. Now, drawing a picture is always helpful for me to think about cosine, and I know between 0 and pi, so right in here, okay, I always have different outputs for cosine. And so when we're thinking about going backwards, I don't want to have repeating outputs since I want to be able to know exactly where to go backwards to. So between 0 and pi, that works as my domain for restricted cosine, or my restricted domain of cosine, which will let me find an inverse. Okay, and if I do that, I see at 0, cosine is 1, and at pi, cosine is -1. So the range of cosine is from -1 to 1. An important property of functions and their inverses is that when we go, here we're going from inputs to outputs, and when we go in the reverse, -1 to 1 become the new inputs, and 0 to pi become the new outputs. Now, one thing to note is that there are multiple ways to write this information, and it'll turn out in our problem that working with intervals is not going to be as convenient as working with inequalities. So if I wanted to write the domain of cosine inverse as an inequality, I could write it as -1 is less than, I'll use x, which is less than 1. Similarly for the range, I could think about it as 0 is less than or equal to y. Since it's the output, we'll use an output variable, which is less than or equal to pi. Okay. Now, secant is going to be involved, and we're putting things into secant, so thinking about the restricted domain of secant is also important. Okay. Cosine and secant are related in the way that secant of some angle is equal to 1 over cosine of that angle. Okay. So we want cosine of whatever angle it is not to equal 0, because otherwise we're dividing by 0 and that's not good. Okay, or not defined. Okay. Again, using these pictures to help me, I see that cosine equals 0 up here at pi halves, or 5 pi halves, or -3 pi halves. There's lots of different angles that correspond to this position. And it's also down here at 3 pi halves, or other angles corresponding to it. Okay. However, note this word restricted. I'm going to have the same restriction that I had for cosine. So the only place where cosine equals 0 between 0 and where the output of cosine equals 0 with inputs 0 to pi is right here at pi halves. So for here, we have domain, we'll start at 0, we'll go to pi halves, but we're not going to include it because it causes the denominator to be 0. Okay. And then we'll pick it back up on the other side of pi halves and go, oops, not to 0, but to pi. Okay. Now, having done all that, we are able to think about the actual problem. So I'm going to go back and I'm just going to think about what is the domain of the inner part, cosine inverse of 3x over 2. And for this, I consider the domain of cosine inverse. I see it has to be sandwiched between -1 and 1. And since my input here has been modified to be 3x over 2, I'll have -1 is less than or equal to 3x over 2, which is less than or equal to 1. I multiply each part by 2 in order to clear the 2 in my fraction, and I get -2 is less than or equal to 3x, which is less than or equal to 2. And then I divide all parts by 3 to isolate x. So I have -2 divided by 3 is less than or equal to x, which is less than 2/3. Now these problems are like onions, and what I mean by that is there's an inner part and an outer part, and you need to consider both parts. We've just considered the inner part, so the next stage is to think about the outer part. So thinking about secant theta, okay, from my work on the domain, I see that theta cannot equal pi halves. So for this problem, that means cosine inverse of 3x over 2 cannot equal pi halves. So we ask ourselves, where would it equal pi halves? And here we can use the way that we're able to rewrite between inverse functions and their corresponding functions. I know that this statement is equivalent to my output, 3x over 2, or I should say it was the input, it becomes the output of cosine of pi halves. Okay. Now cosine of pi halves is 0. So we're left with the equation 3x over 2 is equal to 0, and by inspection we see that the answer is x equals 0. And I lost my not equals. This is not equal to it. We want this not to equal 0, so we want x not to equal 0. Okay. So if x doesn't equal 0, then cosine inverse will not equal pi halves, and we won't be at the one place in our domain where we're not allowed to be. Okay. So we need to combine these two facts, that x does not equal 0 and that we're in this interval to get our domain. So we have a domain. Okay. I'm going to switch back to intervals. We start at -2/3 and I go to 0, but I don't want to include 0. And then I'll continue at 0, not including it, and go to 2/3. Okay. And that is the domain of this composition of an inverse trig function with a general trig function. Okay. Now I'd like to step back and make one comment. Okay. If it hadn't been secant, but it had been sine or cosine, then this would have become a simpler problem. Okay. We would have still needed to do the first step of considering the domain of the inner portion, but when we get here, the restricted domain for sine and cosine doesn't have anything taken out. Okay, and so because of that, we wouldn't have had to consider this. So we could, or in considering this, we would see that there were no pieces to take out. So we wouldn't have to modify the original domain by taking out a piece. So it'd just be a little bit simpler. Okay, there are some great examples in the sections on inverse trig functions in the textbook. So I'd highly recommend, if you want to see more, go there.